Okay.
So
There's no.
yeah, if there's no further question, then I'm done with my quick introduction, and we can go to the main subject of the day. I'll stop sharing and give the floor to Brian.
Okay, great. Let me do some sharing here.
Now you should have sharing rights, Brian.
Yes. I have not super familiar with WebEx, but I think I've got it figured out here. You should be seeing a title slide, Digital Twins Definition Language.
Go ahead.
Great. Great. Yeah, so let's do some introductions first. So I'm Brian Crawford. I'm an architect in the Azure IoT team at Microsoft. And one of the things that I've been working on is the Digital Twins Definition Language that we're going to talk about here. And I've been doing that work with others on the team. Elio's joined us for that. And then we've also got Benjamin from the Azure IoT team as well. And I'll let them do some introductions. So Elio, go ahead.
Hi, my name is Elio Damaggio, and I work in the Azure IoT team together with Brian.
And I'm Benjamin Cabet. I work in the Azure IoT team looking after all things developers. And in a previous life, I was doing lots of open source. Some of you might know me from my days at the Eclipse Foundation and the doing a lot of MQTT, Colab, like with M2M and all that stuff.
Okay, great. So yeah, let's go ahead and jump into the Digital Twins Definition Language. I think we had heard that you had come across the Digital Twins Definition Language and wanted to learn more about it. And so we put together some slides here to talk about that. Did someone have a question or comment? No, okay. So we'll go through, I've got some slides here, but also we just wanted to also say that this, we want to have an open discussion here. And so feel free to, ask questions as we go. We do have some time at the end for more discussion if we don't have it during the presentation. All right. So just to set us up here, this is the agenda we've put together. But if you have specific areas or specific questions, we can certainly, don't have to strictly follow this agenda. This is just what we put together to try to introduce DTDL and talk about some of our experiences and things. So we'll start with a brief introduction of DTDL. We had heard that some of you have looked at it a little bit, but we'll still, just to get everyone on the same page, do a brief introduction of that. And then we've got some information to share on why DTDL. So we've got a kind of a why slide about that. And then we wanted to share some of our experiences with the technologies that we've used to develop DTDL and why we made some of the choices we made. And then we wanted to get into areas for collaboration and interoperability, because we recognize that DTDL is one of many modeling languages that are out there. And at least what we see from our customers is that they use a wide variety of modeling languages. And so we're very interested in how we collaborate and interoperate with those things that already exist and that customers and other people are using. And then we've got some time, if we need it, for questions and discussion at the end. So to start us off, this first slide is kind of a terminology slide before we jump into talking about the DTDL specifically. Just to sort of give some definitions for the terms that we're using. So you'll hear us talk about digital twins a lot. And what that means to us is a variety of things. So digital twins can be physical devices, so actual IoT devices that are deployed in a physical environment. We will call that a digital twin. Sometimes we'll call that a device digital twin if we're trying to be specific. We will have digital twins that represent physical entities like buildings or streetlights or storage tanks, those kinds of things. And so, you know, those aren't devices. They may not directly have directly measuring their environment, for example, but they may have information that is collected from physical devices that represent what's going on in the environment. Then we also have this idea of logical entities, which we also call digital twins. And these can be things like time zones, manufacturers, et cetera. So for example, we've been working with one customer who wants to organize some of their physical entities, like buildings and things, by time zone. And so they will create a digital twin that represents that time zone that they can then use to collect up a set of physical entities or physical devices underneath. So we have those as digital twins. And then this last bullet in the section, semantics is not a digital twin, but it's this idea of across digital twins, we want to be able to attach not only direct descriptions of what those digital twins can do, but their semantics as well. So, for example, understanding that an element in a digital twin is a measurement as opposed to a state is important to us. And another thing that's important to us is not only that that element is maybe a number, but that it's actually a temperature, and that temperature is measured in degrees Celsius, for example. And so you'll hear us later talk about semantics and semantic types, and that's kind of an example of what those are. And then lastly, we also look at collecting these sets of digital twins or systems of digital twins together, where customers can create, you know, full buildings, for example, made up of these digital twins that all interrelate together. And so we'll call this either a graph or a system of digital twins or a set of digital twins, those kinds of things. So I'll pause here if there's any questions on any of the terminology here.
Yeah, a quick question. In terms of physical devices, that's the standard definition, I mean, basic of digital twin. I presume it contains the last known state and reading and whatever data from the device, right?
Yeah, so you'll see when I get into a little bit of the modeling part of digital twins, you can actually go ahead and model exactly that kind of information. So if you have last state information, that can certainly be represented.
And also, just to make sure, a digital twin, by definition, lives in the cloud. It's some sort of virtual replica of whatever thing it stands for, right?
So it certainly does. It's certainly, living in the cloud is certainly one place that it lives, but we've also started to see that digital twins may live elsewhere. So they may live in more local networks, like on an edge device, for example, that is more local to, you know, a set of physical things like physical devices or physical entities. For example, you might have a factory and you may have an edge device that's local to the factory, and that may have some representation of the elements in the factory that, you know, as digital twins.
Okay, thanks.
Quick question on the systems of digital twins. Is there a concept of historical context? So like if a component is swapped out or some logical entity changes, can it be represented in sort of a time series way? Or is that effectively a new system or a snapshot of the system?
Yeah, that's a great question. So at least what we represent currently from the modeling space, we don't directly address the historical, I guess the historical nature of the data. Where we represent that, at least for the service offerings that Microsoft provides, we represent that through, you know, a time series database, for example, where you can collect up that time series data. And the model can then be, and then you could have, for example, in that time, associated with that time series, a set of the model definitions that match, you know, each of the time frames that they apply to.
Gotcha. Thanks.
Yeah. So I'm going to go on here, jump in a little bit into actually what is the digital twins definition language, because that's, I think, primarily what we're here to talk about. So to begin with, our intention here is that the digital twins definition language, or DTDL, is an open source modeling language for describing digital twins. The list we had on the previous slide, so IoT devices, for example, digital twins, as well as the system of digital twins. And so the language tries to include, intends to include enough enough expressivity to be able to express those different things. And we'll get into some more detailed examples on the next couple slides so you can actually see what it looks like. And one of the big reasons why we wanted to introduce modeling and then, and through DTDL in our case, is to enable this contract between the specification and the consumption. So what we were seeing before this is that in many cases, devices and IoT devices and IoT solutions would be very tightly coupled together because there was no contract, no formal contract. The solution had to be written to specific devices and understand the specific interface for each of those devices. What we're enabling here is this ability to specify a contract in a language agnostic way that an IoT developer or digital twin developer could produce, and then separately a solution builder could consume. And that contract is then the common way they exchange how each side works. Another thing we get out of modeling as well is the ability to have contract enforcement and model-driven clients. So with that contract, we can now entertain the idea of having enforcement. So if a digital twin says it has a particular property or state, that could be enforced at the appropriate layer. And then you can also start to build model-driven clients where a client no longer has to say, it works with device XYZ. Instead, it can consume the model and understand that and provide, appropriate UI or whatever for each of the devices that it chooses to use. And then more specifically, DTDL is really a meta model. So we call it the digital twins definition language. But what it really is under the covers is a set of RDF classes and chapel constraints that describe the meta model, which then, in turn describes what you can actually express in a DTDL model. So a DTDL model, we use JSON LD, which we'll get into a little bit in a couple slides as well. We use JSON LD as the main language for expressing DTDL models. And if you're familiar with that, that's really just a set of RDF triples. And in our case, those are RDF triples that conform to our meta model. So although we use the word language here, it's really a set of classes and shackle constraints that describe this under the covers. And our intention here with this is to be programming language agnostic. And we chose JSON LD because we wanted this to be developer friendly and applicable to a broad set of developers as possible. So I'll pause here again and see if there are any questions on this slide.
So JSON LD 1.0 or 1.1?
We are 1.1 right now.
I don't think so. I think it's 1.0. So maybe you have updated the spec, but when I checked that, then there was still 1.0 used.
Yeah, I'll have to go check, I guess. I thought that we had moved up to 1.1 in our most recent parser that we've implemented, which is the library that we use to actually understand models. That's the intention if it's not there. We're not there yet. Okay, so I'll move on to an example here of DTDL just so you can kind of get a sense of what it looks like. So it is JSON, like I said, and specifically JSON LD. And this example model here is expressing an interface, which is really the top level element that we use in DTDL to describe what a digital twin looks like. So interface is describing the interface that the digital twin exposes. And then in that interface, you can express different things. This example shows that this particular digital twin has a property with a name and its data type is string. It has telemetry that it sends that's called temperature, and its schema is double. And then it has a command that is called update that doesn't take any arguments and doesn't return any response. So it's just a simple example here. And then just to expand on that, and I've got a picture of this as well. These are all of the top level concepts that you'll see in DTDL. So the interface is the very top level concept that you use to describe the functionality of a digital twin. And then an interface really then describes the property telemetry command, which we just saw in the previous slide in the example. And in addition, it can describe components, which is a way of expressing containment to other interfaces. It could also contain a relationship, which is a way of expressing a reference to another digital twin. And then each of these property telemetry command, component, and relationship have a schema or a data type. And we support primitive data types, which you saw in the previous example, as well as a set of complex schema types, arrays, enums, objects, and maps. We also support interface inheritance and for specializing your digital twin interfaces. And then lastly, there's this idea of semantic type, which I briefly mentioned before, but this is a way to add additional semantics onto those properties, telemetry commands, for example, where you could say not only is the telemetry, a named temperature and its data type is double, but that it is also measuring temperature and that the temperature units are in degrees Celsius. And you could even get more specific with semantic types. You could say this not only is this measuring a temperature, but maybe this is measuring, outside air temperature or body temperature, different types of temperature as well. And all of that's there to provide that semantic information primarily for solutions that are built on top of this and for machines to be able to reason about this data.
Quick question on that.
Yeah.
Are those variable in the sense, can you add an arbitrary number of relevant annotations to a particular point, or are they limited for a digital twin of a particular type? You can only have certain kinds of annotations.
Yeah, so I think if I understand the question right, you're asking, is it sort of unlimited where you can add these? I don't actually have a good example on this slide. The way we express this is you just add more types here. You create an array of types. And so from that perspective, the array can contain as many different semantic types as you want it to contain. We do currently in the DTDL v2, if you went and looked at the language document, it does have a list of semantic types that we consider built-in semantic types that are a set of common measurement types. So temperature, humidity, etc., velocity, a whole bunch of types there, along with their units. And what we do. And what we've done right now, and this is where it sort of differs between the language definition and implementation, is that the current implementation has some limitations just because of where the implementation is at. But the intention here with the language is to be able to support semantic types across property telemetry command and even properties in relationships at some point.
And another quick follow-up, do you have a vocabulary of those semantic annotations? I'm referring to something like Haystack has a large vocabulary of those, and IoT schema is trying to also standardize them. So do you have your own, or do you use one of those?
So right now we have our own that we've created that that you can easily use from DTDL. But one of the places we actually want to talk about collaboration is how can we start to bring in some of those other definitions. One, now I'm trying to remember the name. There's another one, I think it was QU type or something like that, where there is a set of, like you're saying, there's a vocabulary of those based on standards, a set of useful semantic, what we call semantic types, but a useful set of these, measurement types or whatever you want to call them. Yeah. And this here is just a diagram, really, of what I show, what we have in text on the other slide there. This is not a complete, this is not a complete set, complete class diagram, but this is the main concepts here. I wanted it to be able to fit nicely on the slide and not have everything in here. But the language document that I think you've probably seen, or some of you have seen, and I believe I included a reference to this at the end of the deck, is it has the full list of what can be specified for each of these different classes or types in DTDL. So I'll pause here for questions, or if Ellie or Benjamin want to jump in with anything additional here.
So is it fair to say that you're focusing on the data modeling aspects, but not the protocol level? I don't see any indication of particular URLs or HTML or HTTP.
Yeah, so yes, exactly. So at the DTDL level, we haven't focused on protocols. And there's one area that we actually have later on in our collaboration side, where we want to start to figure out how to express what we call a binding between DTDL and different protocols. Of course, we have one that we use for our own services, and that Microsoft produces. So, for example, Azure has an Azure IoT Hub that IoT devices can connect to. We have a binding, what we call a binding for that describes how DTDL connects to the protocols that are used there. But I think it's an area where we want to actually expand that and collaborate on that more generally.
I have also a question about the data types. Do you have designed your own data type, or do you follow some known data type scheme, like from JSON schema or something like that?
So I guess you'd say we developed our own. I guess it is expressed in DTDL. It's not JSON schema. We looked at JSON schema, but in the end felt that so JSON schema allows you to express data in terms of JSON, and so limited to the JSON types. And we found that in some cases, there were customer use cases where it was more advantageous to be able to have more expressivity in the data types. And so we do have a set of the data types that are in DTDL that, yeah, I guess it's not really correct to say they're derived from the XML types, but they are, that's where we started from, is the set of XSD types that are represented in RDF, but they are not those types in the end.
Okay, thanks.
Yep. Okay, great. Let's go on to, so this slide I called the why slide. When we were prepping for this meeting, it sounded like there were some questions around why DTDL and why choices around JSON-LD and those kinds of things. So I wanted to put together a slide here and be able to have a chance to talk about some of that. And so one of the, one I think very reasonable question is to ask why DTDL and not, another modeling language that already exists. And so we certainly did look at, a set of other modeling languages that are out there, from things like OPCUA and Vorto and others. And all of those are great, and all of those actually we have customers that use a variety of those modeling languages already. for their solutions. And so we certainly want to be able to support those customers. But we also found that we wanted to be able to support these other kinds of things in, in our IoT solutions. So things like device modeling and digital twin modeling, we wanted to be able to bring those things together where it's not only about devices. We wanted to be able to express the relationships between digital twins, where you can start to build up, like we talked about earlier, start to build up those systems of digital twins through a set of modeled relationships. We wanted linking or reuse, where you could describe a custom data type or schema, or you could describe a an interface to a digital twin and reuse those things through linking. And we also wanted to be able to do what we call semantic types, or attach additional semantics to the model elements. So those are some of the reasons why we chose DTDL, why we chose to do DTDL and not directly adopt only one of the other modeling languages. So that said, though, what we actually are expecting to be able to do is customers, like I mentioned, customers are using a variety of different modeling languages, and that's where we want to start to look at the interop between those existing modeling languages and DTDL. We started to do a little of that internally, but I think with this meeting with you, hopefully we can have some more discussion about that a little bit later on. So I'll actually pause here on this first bullet and see if Elio or Benjamin want to add anything, or if there are any questions on this first bullet. Okay, great. So we've also heard the question of why did you choose JSON-LD and not JSON or something else? And when we started this, we actually were pretty sure that we wanted JSON, both because it's programming language agnostic, and it's something that many developers, a broad set of developers are familiar with. And so we started there. And then as we got into sort of looking at modeling and using JSON and looking at other modeling languages that are out there, we realized that we wanted reuse and linking, and JSON-LD is really great for that. And trying to do something else, in JSON and you have reuse and linking would probably just lead you to inventing essentially JSON-LD again. And so we pivoted to that primarily to be able to pick up that those concepts of linking that have proven to be useful now for us. And we wanted this idea of semantic types, and JSON-LD and RDF really allow that to happen. Another thing, I guess that's not on the slide, is we also wanted the ability for multiple authors to be able to provide information about a digital twin. So if you imagine a device manufacturer describing their device through a DTDL model, that's great. They can describe a bunch of information about that device, but what they probably don't know is how that device is actually installed. Is it installed outside or inside? Does the solution that's going to use that device expect the data to, expect data there to be stored historically or not? So there's some solution level information that another author may want to provide. And so what we found is that, through RDF and JSON-LD, the ability to be able to provide information after the fact, or in addition to a model that was provided by an original author was present. And we wanted that idea as well, so that we can have, so that you can build up a view of your digital twin over time from different authors. So I'll pause here again for questions on this second bullet.
Well, I was just going to applaud you for doing that. I think following it throughout the life cycle of the node and of digital twin is a very good approach to take, because different things happen at different times in the life cycle of the system. So I think that's useful.
Yeah, we think so too. And while we haven't fully realized that in our in our current implementations, if you were to look at those, that is something that we do have on our roadmap, and that's one important thing that we're getting out of JSON-LD.
Yeah, the funny thing is we had actually some similar discussion a few years ago with the thing description, and this really reminds me the discussion which kind of format we would like to have, RDF or JSON-LD or ontology, etc. And yeah, the best way was JSON-LD. Yeah, was a good decision.
Yeah, yeah, we've been pretty happy with our choice of JSON-LD. I actually have a slide on JSON-LD. I think maybe next that we can talk some more about our experience there in more detail. I'll spend just a brief couple comments on these last couple bullets. I think these get into more details that if we're interested, we can certainly talk about, but I won't spend a bunch of time here unless there's interest. So one thing that we've seen with some approaches, in particular when people use OWL ontologies and then create what we call instances or entities of those classes, is that they actually use triples for both the class definitions as well as the instances or individuals, and that certainly works great in that environment. And so you can ask the question then, well, why didn't we? And maybe you don't even have this background, but we actually currently don't represent our entities or instances using triples. And so you could ask the question why we don't do that in our implementations. And we just found that really developers weren't quite, broadly speaking, developers weren't quite ready for triples. And we didn't want to have to push the requirement to do triple processing or JSON-LD processing onto customers for every entity. And so we actually have this split where we use JSON-LD, RDF, et cetera, for the modeling side. And then on the instance or entity side, we just use traditional REST APIs with just JSON entities.
Would you mind going back and talking a bit more about your use cases? So what kinds of contexts and applications do you see this being used in?
Yeah, sure. And Ellie or Benjamin, you can jump in here as well, but I would start with there's actually a broad set of different use cases that we see. So one set of use cases we see are the physical devices that are connected into the cloud. So you may have a set of devices that are monitoring some a manufacturing line or monitoring something in a building, those kinds of things. Then we get, and so there's sort of a set of device oriented use cases where you've got those physical devices, you want to do device management over those devices, you want to be able to collect data and analyze data and produce insights from the data coming from those devices. And the modeling there helps us, helps the solution understand what the data is that's coming in. Before we had modeling, the solution would have to essentially be coded to understand this piece of data is going to be a number, this piece of data is going to be a string, whatever. And then when we go more into our digital twin space, we get into use cases like buildings, building management, or city management, those kinds of energy grid management, those kinds of use cases where people want to be able to model things that aren't devices. They want to be able to connect them together into systems, and they want to be able to draw data, aggregate data, produce insights from that data to be able to improve energy use in a building, for example. And so from a modeling perspective, we want to be able to provide, again, the modeling there where the solution can understand what the entities are that they're connected to, so they can understand the difference between a building and a floor and a room and those kinds of things.
Right. So just a follow-on question. Can you compare this to like what platform 4.0 has been working on? And in particular, it doesn't seem you have behavioral modeling explicitly laid out here. Can you comment on do a compare and contrast with like the platform 4.0 language, which you may have forgotten?
So are you asking about
Well,
The,
4.0 has a language that they use to define digital twins. And they actually have a very broad scope and have a lot of different aspects of digital twins, including behavior modeling. I guess the question is, have you, can you compare and contrast with what Platform 4.0 has been working on?
yeah, and when you ask that, are you talking about OPC UA in that context or a different modern
Yeah, I
language?
can't remember the name of the language. Does anyone here on the call remember it? There's a particular standard language that Platform 4.0 has been defining. You know, I'm blanking, and I'll have to get back to you on it. Never mind.
No, that's okay. And I was pausing there to see if Ellie or Benjamin knows. So OPC-UA we certainly see in Platform 4.0 and in industrial IoT, which I think is what you're referring to when you say Platform 4.0.
No, I'm not. There's no language.
Oh, you're not.
It's not tied to OPC UA. It's more general modeling language, more like yours. And
oh, okay.
I wish I looked at the name while you were speaking so we could refer to it. But yeah, it's similar concept. I think it also includes like state machine definitions and things like this. So behavior modeling. So
I don't know that I'm familiar with it then.
Okay, well, maybe we'll follow up offline. I'll have to look it up and bring it up next time.
Yeah, definitely. Let's do a follow-up offline on that, because it'd be great for us to learn about it as well and understand that and be able to connect that. Figure out how to connect that, or interoperate between that and DTDL. Okay. Okay, so I'm going to just, we talked briefly about our experience with JSON-LD, but I created a slide here just because we've actually been pretty happy with using JSON-LD. So one of the first benefits of it, of course, is it's JSON, and that's great because that's pretty well understood by a broad set of developers, and there's lots of tools, there's lots of support across a broad set of languages, programming languages, which is great. But of course, it's also more than just JSON. It actually brings in the linking, of course. We found that the spec was a well-written spec, and that there were enough tools and libraries for us to learn about it and use it and be successful with it, internally before we even went to customers with it. We found in particular, obviously, Microsoft is using a variety of languages, but of course .NET is still probably more used at Microsoft than other languages. We found that JSON-LD had great .NET support through some open source NuGet packages. We also do heavily use JavaScript in some of our projects, and we also found good support for JSON-LD in JavaScript. And we ourselves haven't had a chance to dig deeply into Java yet. But it does sound like there are some libraries that I just can't, we just haven't dug into that to understand the level of support. So that's been really good for us and for our customers. One of the things, of course, that JSON-LD brings in, and this is really an RDF or semantic web thing, is the open world assumption, which is not natural. At least what I found is not natural for many things, or for developers and the way developers think. And so we actually use Shackle and Shackle concepts internally to put constraints on this. So, for example, most developers, expect a thing to only have one name, but with the open world assumption, a thing could have many names. And when I say name, I mean like the programming name for a thing. They typically expect they've given it a name and it has that name, and that's the only name that it has. And so we do want to meet some of those expectations. And so we use internally, we use Shackle, which, if you're not familiar with it, is the shapes constraint language for RDF. And I say Shackle concepts because there were some cases where we wanted to be able to represent some constraints that weren't part of Shackle. And so we use the same concepts internally to be able to put some of those constraints on DTDL so that it more matches what a developer expects. But we also do like some of the benefits of the open world assumption, like the semantic type idea, or the idea of, that we talked about earlier, the idea of multiple authors contributing to the definition of an entity or of a type. And so, you know, we actually get benefit out of the open world assumption. In some cases, we put constraints on it. As we expand out from just JSON LD into some of the other related technology, like Shackle, the shapes constraint language, Shackle does cover a lot of what we need. And we did find there were some constraints that we wanted to express that weren't directly expressible in Shackle. And if you're familiar with Shackle, Shackle has basically an escape clause where you can use Sparkle, which is actually it's the query language for triples. I don't actually know if I know what it stands for. And we went down that path of using Sparkle to express some of those constraints, but we found in our implementations, in our particular use cases, that the performance of at least the way we were using it in our solution didn't meet our requirements, and so we've backed off on using that internally for now, and going to just some some code that expresses those internal code that expresses those constraints. So I'll pause here in case there's any questions or any comments or anything.
Yeah, one of the, now that you mentioned Sparkle, one of the other things that I have done this week was kicking, excuse me, kicking off standardization of JSON path in the IETF. So I mean, this is a very simple language, but people like the simplicity, and sometimes it actually matches simple IoT devices very well. So I hope we will be able to point to a standard there within a year or so.
Yeah, I was going to say something similar. So in Web of Things, we've been looking at discovery. And discovery is basically getting access to the metadata about devices. And part of that is doing queries on databases. And so part of the reason to have semantic annotation is to be able to find stuff like all the lights in a certain area. And so Sparkle really, I mean, it can be used for constraints, but it also is obviously a query language, but it's a bit too powerful for constrained devices. So JSON path is not just like, doesn't just let you point at part of a thing, lets you do queries. It's actually related closely to XPath, and XPath, even though it's for XML, now is JSON support. So we've been comparing and contrasting those two query languages, but they're more syntactic query languages. So you can search for particular terms, but you can't search for things that are like derived by inference from other terms. You can't with Sparkle. But it's still pretty powerful and pretty useful if you have a fairly constrained semantic tagging.
Yeah, no, that's actually super interesting. So right now, in what we've done here with both Shackle and Sparkle, is we haven't exposed that to customers. These comments are more about what we use internally to actually implement the various services and tools that we have around DTDL and models. But I think what you're kind of getting at is actually there is value in exposing at least some of the query side for people to be able to use. Yeah, I think that totally makes sense.
Yeah, and actually the other problem with exposing a Sparkle endpoint is because it's so expensive, you're just asking for trouble. People in your system by intention or by accident. Whereas something like JSON query is much more straightforward and much more controllable. Although you probably want to limit the use of arbitrary scripts in it, which it does allow. The problem though with JSON path though is not really got a really good spec right now. Just like a blog page, and so it, as I think was alluded by Karsten, it needs some work to turn into a real spec before we can really deploy it.
Yeah, no, I think that makes sense. Yeah, we I think probably aren't at the point where we would entertain exposing Sparkle because of the reasons you just said, but having something more constrained where we can actually provide some controls at a service level, or even at the level of code running on an edge or even on a device. that would be useful.
Yeah, I think one interesting question is there an intermediate level between Sparkle and JSON path? So if there's some way to do simple inferencing, for example, limited in some way so that it's not just syntactic matching, but we can do Sparkle-like things without having all the bells and whistles that Sparkle has. I think it's an interesting question.
Yeah. Yeah, I think that's a good question too, because Sparkle is very powerful, but it can also cost you a lot if you write your query incorrectly or maliciously or whatever.
Yeah.
Okay. Yeah, so now I think the next couple slides get into some of the, sort of expanding beyond just what's in DTDL, but actually how DTDL interoperates and where we wanted, where at least we've had ideas around collaboration. So to kind of get us into that, this slide talks about some ideas that we have around interoperability with other specs. And so in particular, we've been internally looking at, OWL ontologies, as well as OPC-UA information models for industrial IoT. And so when we sort of think about DTDL, really that meta model, if you will, is that it's analogous to OWL or the OPC-UA information model. And then the DTDL models are those, either the things you express using OWL or the models you express using the OPC-UA information model, for example. And in many cases, at least for the things that we've looked at and experimented with, we've seen reasonable transformations to and from DTDL models. We don't think they're perfect. We think that they're, depending on what features of different modeling languages have been used, that not everything may be expressible, either in DTDL or maybe there's some things in DTDL that could be expressed somewhere else. From a DTDL perspective, the way we've looked at this is using semantic types or extension types or whatever for this interoperability or extensibility. And so this example here that I'm showing, if you're familiar with OPC-UA, OPC-UA has node IDs in this particular format that identifies the node, this I equals number structure. And in DTDL, for example, that contains characters that aren't allowed in a DTDL name. We don't allow the equals. We only allow really alphanumeric characters because it's designed to be used in programming languages. And so, you then have this problem where this particular, if you were translating between OPC-UA and DTDL, how do you represent that special ID that OPC-UA has so that you don't lose that data? So that you could go into DTDL and still then consume a DTDL model that referenced back to some, OPC-UA element. And what we've looked at here is this idea of these extension types, which you can see an example of here, where someone could define an extension type. I just made this one up called OPC-UA property. And so on a property in a DTDL model, I could add in this additional type that's called OPC-UA property. And then that property can come with, its set of properties that can be expressed in that element. In particular, this one, I just made this up. I called it node ID. And that node ID could carry that extra information from OPC-UA. So we've started to look at this idea of being able to carry information along in DTDL that may not be directly represented in core DTDL through this extension type mechanism. Now, this extension type mechanism is more right now kind of on paper. There's a little bit of it implemented, but it's not fully there in all of our implementations yet, but it's something that we're experimenting with. I'll pause if there's any questions or comments on this one.
Yeah, you seem to imply that your processor would only recognize the node ID, keyword, let's call it, if you also have type OPC-UA property. Is that the case? I mean, you don't have to add something to the context file to get it to recognize that?
Oh, actually, you're right. There is a bug on this slide.
Oh, okay.
There would be an additional context here. you're absolutely right. So
no big problem, but yeah, okay, cool.
yeah, exactly. So no, but yeah, there would be an additional context to bring in the definition. That's actually how we've looked at adding, allowing model authors to express the use of additional extension types is by adding additional context. That would then you would then have, in essence, the definition. And if you look at this from a DTDL parser perspective, what happens there is that the parser actually would expect to be loaded with what we call, I guess, call a package. We haven't settled on all the names, but a package of the definitions of what OPC-UA property is. Essentially in a set of RDF classes, and we would our DTDL parser then would then say, okay, I now understand what OPC-UA property is, and I understand that it has this additional field called node ID, and so this actually then does form a legal DTDL interface, and in particular a legal DTDL property, because it understands that additional extension.
So does the shackle processor help you do that, or do you have to write additional code to associate those two? It seems like shackle might be able to do that, but
I would have to go. So I am not the expert on everything we did with shackle and outside of shackle. I'd have to go look specifically. But yes, we are using where we can. This is exactly where, at least in our implementation in our parser, where we do use shackle to say, look, this like property is defined. Actually, now remembering. So when we define property ourselves, we define it as an RDF class, but we also define the shackle constraints that go with that. And that is where we say property must have name, and it must be a string, and it must have schema, and it must be, one of these elements. And then optionally you could have description and display name and those things, right?
yeah, the shackle rules are what you normally would do with like a JSON schema. To process a JSON, to process a JSON LD, you use shackle rules.
Yep. And so then when someone authors this OPC-UA property element, they would do the same thing. They would describe it, what they can describe in RDF, they would describe that as an RDF class, and then they would also provide the constraints. So like, for example, OPC-UA property might always require node ID to be there. That could be expressed in that extension.
Thank you.
Yeah. Okay. Yeah, and so then that sort of leads us to, and this is one of our last slides. I think there's a discussion slide, yeah. But so this is really leads us to hopefully where maybe we can have a little more discussion, and kind of gauge interest. But we've put together a list of areas that we are interested in collaborating on, things that we want to get more into with DTDL. And so that's this list you can see here. So I've talked about some of these already, where conversions to and from other specs, OWL ontology interoperability, because we see a number of at least our customers using OWL ontologies for different things like building management, energy grid management, those kinds of things. More collaboration around extensibility. We've mentioned protocol bindings before. And then this other one here, this cross-language open source software stacks, is we found, like I mentioned before, we found some really good libraries in some programming languages, and not as much support in others. And so we're interested in that as well, in sort of beefing this up to having a good set of cross-language open source software stacks for really primarily JSON LD that would be production grade and that would be tooling ready for us as well. And then more stuff that we probably haven't thought of, but and then lastly, I just mentioned on this slide the Digital Twin Consortium, which is a consortium that Microsoft and many other companies and organizations are a group of, where it's designed to influence digital twin technology, and it's a place where it looks like there's some collaboration that will be starting up there on DTDL. So yes, I wanted to pause here and actually kind of open things up to discussion, other ideas for collaboration, find out what you're interested in, where we can work together more.
Yeah, I have a comment. So I'm Sebastian here. So did you already aware of the W3C Web of Things activity? Since we started a new charter beginning of this year, and we have there the topic Thing Description Template. And the Thing Description Template is actually, I would say, 100% identical what you're doing. And I did a few months ago, I did a kind of comparison of DTDL and Thing Description Template. And if you like, I can quickly show you the comparison if you're interested in. And
Sure. Yeah. Do you want to do that here or at another time?
it's just one slider which I can share you. So
let's do it. Do I have to?
Yeah.
I'll stop sharing.
Yeah.
Yeah, and just so you have some context as well, we have been looking at Web of Things and sort of keeping track of what's being released there publicly. And I agree. Like there is a lot of overlap and similarity here, and so I think it would be great to to have some more discussions. We've seen Web of Things sort of evolve over the years, as as you can imagine, DTDL evolving as well, and so it's been good to see.
I was already in exchange with Chris Green. Is he still involved in that topic?
He is no longer involved on that, so we should probably, have you connect with others, me for sure, and Elio, and probably Benjamin as well.
That's then I understand why he's maybe not answering my emails anymore.
Yeah.
Okay,
Yeah.
so I understand. Okay, but can you see my screen or my slide here?
Yes.
Okay, great. So I did a comparison with the detailed DLL version. I think this was the first version, so it is not up to date, but I think it still looks very similar. And
yeah,
and I compared this with what we are named as Thing Description Template here.
Mm-hmm.
And I took example from your web page, and I said, okay, let's define completely the identical thing with Thing Description Template, and you can see there's really the identical information in there. The except change is that we just say, okay, this is as the Thing Description form, so we have our own namespace for that, that is hosted by the W3C. And what you see here, I just integrate your context, which you have defined also here in the on the button. Can you see my mouse?
Yep, I can. Yep.
Yeah, so we just integrate that, and then we are simple, define all this identical stuff what you have there. So you have ID here, you have the add type here. So we have the thing as a core class definition and thing description, which we integrate. And then I simply say, okay, this definition follows the interface from the DTDL. Except of the display name, we have using title. The title is something, yeah, it's just a different name. And yes, and what is also a little bit different, but only a naming thing, is what you call as property command telemetry is at W3C Web of Things property action event, but completely the same intention. That, yeah.
Sebastian, you could still add @type telemetry in the definition for the temp event and actually connect this semantically to the DTDL ontology.
That's right. Yeah.
And so, one.
And you could say @type Azure property or whatever, Azure :property, Azure :telemetry. Yeah, that would help.
I also want to say we shouldn't put too much emphasis on the change in syntax, because in fact our original syntax for Web of Things looked very much DTDL under JSON 1.0. It's only when we went to 1.1 that we could switch to the map approach that was a little bit cleaner and a bit more, didn't have to have all the at types everywhere. But I think we should look in the devils in the details here in terms of are they really interconvertible? Are there details in how you handle events, for example, that don't map one-to-one? So I think it'd be useful to look into the details here, but I think, yeah, at the highest level, they are very clear. The one thing we do have, though, we have forms, which basically create a protocol binding.
Yep.
So there is this additional aspect in TDs and protocol plans.
Yes, that's right, but this is not focused in the template, right? The template is actually information.
That's true.
In terms of integration, this week you could provide a TD template and a TD that would give a web of things interface to a DTDL system that uses DTDL. And likewise, you could probably import things as TD templates into DTDL. So it could probably work both ways. You could have things that are described using TD that you could import. And it seems like this is pretty low friction and low loss.
Well, the question is, can we turn that probably into a certainly? You know, is there
run it in a plug fest?
Yeah, is there a project we can define where we really, you know, try to build a bidirectional converter, for example, and really discover whatever all the little, you know, corner cases and things. I suspect there are some, especially under events and actions, because we ran into a lot of fun things about, and things like, you know, but I think it's definitely worth looking at to uncover gaps at the very least. But yeah, I think if it's just a different syntax and there's a bidirectional converter, then for example, having links in a thing description that point to a DTTL as its, you know, template would then be feasible if they can be formally interconverted.
Yes, and I actually think that's a super interesting idea of being able to just from you know, from a model being able to reference another model that is at least you know, is maybe RDF under the covers. I'm very interested in understanding where we can do that versus conversion. Like I think conversion is, you know, is useful and is probably valuable in many cases. But I can also imagine if someone's already got their TD template, for example, or a set of those for their solution, why even convert them? Could we reference those? You know,
yeah,
that would be great. Or the other way around.
Formally converted, I just meant, are they semantically equivalent?
Yeah.
If it's possible to do a one-to-one conversion, then they're semantically equivalent, and then you could just, you know, get the information directly. And I'm just saying, proving that they're equivalent can be accomplished by building a converter. I guess another question here, though, is what's your standardization plan? So are you planning to you know, proceed with a standards body for DTL?
Yeah, I don't know, Elio or Benjamin, if you have more, if you would have more context on that question.
Hi, this is Elio. We're the long-term plan is definitely we would like to make this a standard. We do not have a plan that is publicly shareable right now. We're definitely working on it. We're very eager. We know that to a certain extent we're late starting that. We're just like so busy getting stuff out. So that's definitely high on our priority, but we don't really have like a specific plan. We're also open to suggestions. I think Brian was like very good with that. If we say, hey, look, should you consider this organization or this specific thing seems relevant, we're definitely open to those kind of suggestions as well. Well, we're doing our own process internally, but definitely very open to see what's the best avenue. We absolutely want to have like an open stance. We're working on how to have a more formal way to start collaborating on the new things that we're doing on this. And we're definitely eager like to start being to make this like more of a standard and open process, open development process, like in general.
Hey, oh, go ahead.
Yeah, I don't know how you are open to maybe to that we maybe can invite you to one of our next Web of Things meetings where we're discussing the template stuff. And I don't know if you're interested. I think we can, plan something and it can join of our meetings.
Yeah, I think that would be great. And I know we haven't really reached out on that. It sounds like you've talked to Chris Green in the past, and it sounds like we should, you know, refresh that contact and conversation, get that going a little bit more.
Yeah, and this was actually what I was with Chris Green exchanging, and yeah, and then one day he doesn't answer anymore, and so. But I think it's really almost identical what we're doing, and I think we will be more strong. Can work with this on that. And right, and if you are planning to also to address protocol bindings, I think this is what we already did in a couple of years about this, and have a lot of experience and addressing this in Plugfests, etc. I think you can really benefit of that.
And this is Benjamin speaking. Can maybe the group at large help us at Microsoft understand where you would see in the future the discussions happening? Because I mean, there's DTDL. We're on GitHub, so maybe like the particular example that you shared, Sebastian, that could be an issue where we discuss the stuff. But of course, that also has some Web of Things bits to it. So discussion could also be on the Web of Things mailing list, and or this could be someplace else. Where do you guys see like the best forum to have at least the public part of the discussions, which I hope would be the bulk of the discussions?
You know, one constraint of the Web of Things meeting is we have to satisfy the W3C's patent policies, etc. And there's different forms of meetings we could adopt, but it would essentially be public. See, if you want to have, you know, under NDA or some under intermediate form of confidentiality, we have to make different arrangements. But if you're on public GitHub right now, I think it's
Yeah, and Microsoft is member, of course, member of the W3C, and they are also member of the Web of Things interest group. So it's quite easy to contribute.
Already agreed to the legals, so it's just a matter of making sure what you state in those meetings is informs what you don't say under those constraints. So certainly that's feasible, and as we said, we have a charter to build a template definition. So I think, you know, that would be one path for, you know, the like abstract standardization effort. Right? Might tweak a few things to bring things into alignment on both our sides, but I think it'd be very valuable for us to be in alignment a year and a half from now, right?
Mm-hmm.
I think having two different standards that differ only in the names of things is kind of awkward.
Yeah. Yeah, I think it'd be great to have some more conversations around this in particular.
Yeah, well, you asked what would be a good forum for conversations about this. You are in one of those forums. So this is exactly what we have created Wishy for, to get an open conversation going on between different players. And of course, it would be possible to continue this conversation here as well. Before our time runs out, I wanted to quickly show a couple of slides that we made this morning. Sebastian, I'm going to steal your presentation.
Yeah.
There we are. Examples. Can you see my slide?
Yeah.
We looked at one of the examples in the GitHub repository, which is copied here on the slide. It will look familiar to you. Of course, it's another thermostat. And there are things in there like telemetry, property, and command, which are in SDF events, properties, and actions, and various descriptions and schemas and so on. And there's also, for the action here, the temperature report, there is a return type which is described by a schema. And essentially the terminology here pretty much maps to SDF terminology. So property action event is property command telemetry. Object is probably close to component. We may have to work a little bit on the object terminology. Input data and output data is request and response. Label is display name. and so on. So that's pretty much a one-to-one thing. So it will be pretty easy for a translator to actually handle this. And then, of course, there are things like JSON schema org descriptions, which I think you did good not to include. These can be mapped with little effort between DTL and SDF. So it should be easy to write a converter from DTL to SDF. And we just went ahead and translated the thing into SDF, and you can see it actually looks pretty similar. So it invents a few new terms like SDF thing here, which is the whole thing, a temperature controller with a property that is serial number and is of type string. So that's just a different way of doing this. Then we have an action called reboot, which has input data which is defined somewhere else here since. And in the thing, we have two objects, thermostat 1 and thermostat 2, and some device information. I have no idea what that is. We didn't get it this morning. And the actual thermostat is an SDF object, which in turn has an SDF event. And that is a little bit clumsy in SDF right now. So you have to have a pointer to a data structure here, the SDF output data. Maybe we can clean this up in the next version a little bit. We have a property, we have two properties, target temperature and max temp since last reboot. And again, these are JSON schema org type descriptions with type number. Units is something that is specific to SDF, that is using the CNML unit names. And we could make another table that maps the CNML unit names to the GTDL unit names. So it should be relatively easy to get a converter going between the two. And this is really what we are trying to push forward in the SDF world, that we actually have converters. And we have a process called pressure testing, which means we feed models into the converters and see, can we actually generate useful SDF for that? That is essentially what moves the language forward. So for instance, if you look closely into this SDF action, that is a little bit clumsy how the output data is defined with all these JSON pointers. So maybe we can make this a little bit simpler. Yeah, and the actual SDF data, the data types that are defined here are pretty straightforward. So this is really one of the things that we could push forward quickly, make sure we have the converters available. And to do this, of course, it would be nice to have more than 2 DTDL models. So if you have 100 or so, that would be good for actually pressure testing converter. So if you can point us to resources we can use for that, that would be very useful. And of course, it would also allow us at the SDF side to make sure we actually can take in these DTDL models and represent them in SDF.
Yeah, I think this is really encouraging, actually. I have to apologize. I'm not super familiar with SDF, but I already took a note earlier on to go learn more about it after this meeting. So I will definitely go do that for myself. I think in terms of getting more DTDL models, we should be able to provide some more of those. You know, many of the ones that we're working with that we see internally are from customers, and so we probably wouldn't be able to share those, but there probably are. I do believe that we have a good set of example models for sure around the digital twin space, so things that are some devices, but also some non-device things. And so I think we can probably pull from those examples and tutorials that we have to get a better set here.
And just to ask, are you familiar with the one data model work?
I guess for me, and I don't know if Ellie or Benjamin are, I've heard the name, but I actually also haven't spent enough time to dig in there. So I've got that note as well that I took, even when you were talking about it before our meeting, before our part.
Yeah, it would be interesting to look at how you have models to represent things like the temperature transmitter, or level control or something like that, right? A PID controller. You must have some generic DTDL models that aren't super specific or proprietary, and just to see how the URIs map to the concepts and is an interesting thing, because we have that as really application vocabularies as this other layer that I would say IoT schema and one data model mostly work on. And it seems like you have some intersection around creating these standard application vocabularies as well.
Yeah, actually, to that point, we've actually, for now anyways, sort of purposely stayed away from trying to create, a set of models for, for any particular domain, whether it's, IoT devices or building management or energy management or anything. More thinking that what we want to try to do there is engage with the domain experts to help us build those up. And so we don't currently have, we aren't currently pushing, a set of, if you're implementing a thermostat, you should use this DTDL model.
Yeah. So actually, I think one data model has two things that are interesting. One is the large collection of actual device models. The other is just kind of a framework in terms of capabilities and objects and kind of like a modularity. And one thing that occurred to me previously, I had mentioned, we have this gap between full SPARQL semantic queries and kind of pure syntactic queries, which only give us one, particular keyword. I think an interesting intermediate zone there is if we have, a particular semantic structure in place that is, for example, hierarchical. Like maybe we don't allow cycles and graphs, we only allow like trees or some kind of more strict subclassing mechanism. And the inferencing becomes a lot easier and a lot more efficient. And it might be very interesting to look at, more constraining semantic models that are still powerful enough to capture the things you want to talk about in IoT space.
We kind of have that, and I think that if you look at where some other work is going, and maybe what Milan is going to show later, we're working on aligning the semantic categories across. I've looked at 14 different models, and so that gives us this consistent meta model that does provide a part of the constraint that you're talking about.
Yeah. So I think it'd be very interesting to think about also, like I said, what kind of inferencing do we need? And I think a lot of it is simply superclass, subclass type of inferencing, right? And that can be a lot more efficient than just general graph, inferencing. And I think, maybe we should talk about, what kind of semantic inferencing or abstraction capabilities do we need in a query language? And how does this map onto the structure? Anyways, I think the one data model is not only talking about this, collecting a bunch of models, it's also talking about structure.
Yeah, and I actually think that point's really interesting. How much inferencing do you actually need for solutions? What we're seeing right now is many of our customers aren't really there on, needing inferencing or understanding what the use cases are. So we ourselves I would say don't fully understand what's needed there. Right now, customers seem to be at the place where they do want a graph of digital twins, so a system of digital twins represented. They want to be able to model that graph as well as have the entities or instances of that. And then they want to be able to query that at least at a graph level, So I know I have a device failing, tell me what building that device is in, right? And so that's sort of right.
I think doing some like thought experiments about, I am a user, I need to do this task. What kind of queries will I write? I might want to know what kind of lights are used for task lighting. I need to access all the task lights or all the hallway lights or, or all the incandescent lights, or I need to look at power consumption for things on this floor. I think if we think about, work through it, what kind of inferencing capabilities we want, I can certainly, like I said, I think abstraction, I want to know all the lights, not just the incandescent lights, right? So I need to have like a superclass ability to search for things. Maybe I only tag things as being, a certain, model of light, but it's a subclass of the more general classic light. So I search on lights, I should pick up all the things that are tagged as fluorescent lights. So I think we can define some use cases and then go back I think the opportunity exists when you're talking about JSON path standardization. Maybe there can be some simple extension of JSON path as part of that that lets us capture some of these use cases. But
Yeah,
I think first we need to talk about what we want.
Yeah, I think that actually sounds like, I just took a note there, because it sounds like this could be another good area of collaboration for us to, figure out what are the use cases, and then what does that look like in terms of query. That'd be valuable for us as well.
Okay, I put the agenda slide because we have 3 more things we want to do. Maybe we should, because I have the projector right now, quickly do one thing, which is talk about the next meeting, and maybe we can continue some of this discussion there in the next meeting. So we are meeting in Vichy about once a month, but probably should be pausing in August because Europe shuts down in August. And we're right now looking at the next meeting in mid-September in week 38. Sorry, we Europeans have that weeks are numbered, so it's September 14th to 18th. Is that fundamentally a bad idea for anyone here? Okay, so what we will do is we will send a doodle to the Thing2Thing research group mailing list, and everyone who is not subscribed to that, this is a low volume mailing list, so it's probably a good idea to join that, to know what's going on in the Thing2Thing research group in the Vichy activity, and then we can look when exactly we are going to have the next meeting.
Okay, question. I did put in the minutes all the Web of Things conflicts that I know about for the next year, basically. So.
Mm-hmm.
Yeah, and I had a question for the uninitiated. Week 38 is what? Which date would that be?
September 14th to 18th.
Okay, thanks. Intel had the manufacturing work weeks that started not according to calendar, so work weeks can be confusing. Okay.
There is an ISO standard for these week numbers.
No, there's a standard for everything. For that.
Okay, so any other things we should be doing about DTDL before we go to the last 2 items? So I'll wait for some pointers from Brian to more DTDL models we might be crunching. Is there anything you would want from us?
Yeah, I mean, I think the things we had talked about from our side that we wanted to get out of this call and is how to collaborate going forward and what the areas of collaboration, areas of interest are. And I think we got some of those and as next steps. So what I've got is, yes, sending some more models, and then also looking at collaboration between SDF and DTDL, as well as Web of Things and DTDL. And I should say 1DM, SDF, Web of Things.
By the way, Brian, if you look at it, 1DM and SDF are kind of 1DM, or rather SDF comes from the 1DM group. So it's basically the same thing in the sense it's not 2 different things, except it also has the data models that Michael mentioned earlier as part of its work scope.
Yeah, okay, that makes sense. So those things, that's what I have in my notes, and those seem like good for me, good next steps and areas to start. Does that match what others were thinking?
Yeah, and I think concretely for Web of Things stuff, I sent an email to me or Sebastian, and we can collaborate on those things. And I guess for SDF, I suggest Michael Koster as being the point of contact.
Great. Thanks.
yeah, I was a bit distracted. Yes.
Sorry to volunteer you.
Yeah, I was
Thanks a lot,
actually.
Brian.
Yeah. Mhm.
This has been super good, and now I wish we would have booked even more time for this discussion. But very much looking forward to the follow-up discussions and see what comes out of this. So
Yeah, no, thanks.
joining today.
Well, thanks for reaching out to us. I think that Jonathan might have been the one who first reached out. I'm not sure. But anyway, I'm glad we got connected, and actually thanks for having us join your meeting and giving us a chance to share what we're doing with DTDL.
Absolutely. And let's keep this up. And very much hope you'll be able to join to the follow-up meetings mid-September, and we can take it forward from there. Unfortunately, I will be still away in September, but looking forward to see where this goes when I'm back in game.
Yeah, I think that sounds good.
Okay, wonderful. So that was a pretty good segment. So yeah, Milan, do you want to talk about the semantic technology landscape update?
Yeah, I don't have much, so in terms of, I'm trying to share my slide, but it's not showing up.
And if you can get a little bit closer to your microphone, that would help.
Was that the problem last time? I supposedly had fixed it. Does it not show?
It still sounds like you're about 200 meters away.
Still? Okay, anyway.
Slightly better.
I'm fixing that now, but,
Yeah, slightly better.
now what happened? I'm sorry, the disappeared from me and I got the Microsoft share out now.
So for those of you not familiar with WebEx, you can actually zoom in WebEx. So it's not necessary to make this full screen.
I'm trying to share the app and now it's not showing me that option, which normally it does.
WebEx is a bit weird.
No, I was using it yesterday, but it seems like a different version of WebEx. I have something, I'm sharing
Just zoom in. Just everyone can zoom in with the controls at the right side of the slide, and then you can move the image back, and then you will have something like a full screen view.
And it now disappeared on me. Okay, it's acting up the WebEx for me, but let me leave that alone. I mean, we won't be debugging it. Now, so you do have something, right? I see.
I see a slide, and if you can avoid putting other windows on top of this, thank you.
I'm trying just to share the content, not the slide. I can make it bigger. So.
I think it's good enough the way it is now. I think we should just proceed.
Okay. So anyway, not much has happened. I just thought in terms of what needs to be done. I guess everybody remembers it was a month ago already. We discussed whether we should do a document that does a description of IoT standards in a common way so that one can relate. So basically do the abstract definition of the problem and the concept. Actually, I have that slide. I wasn't sure if Microsoft guys are going to be there or not. But we wanted to create a paper, the DRTG draft, that does standards description in a consistent manner. And we discussed what it shouldn't do. I did a straw man on the common criteria. There wasn't proposal, not much discussion, and Michael Koster and Michael McCool offered to contribute some of the previous work and the work in progress that they had. So in terms of, so I was thinking, okay, we need to start, and I have some pros that I want to use for this document, at least that I will use in the initial draft of the document. And so we need to start the document. I don't know if there are volunteers other than myself who can do this in two ways. I can wait for volunteers, or I can, again, do a straw man write-up, and then we can pile on that. My belief is, and I don't know if that's shared by others, that we should aim for a more general audience, not just info model connoisseurs like us. I mean, people who are familiar with at least one, probably several models, but rather to somebody, a more general practitioner or researcher of IoT who basically is kind of aware of the problem, but not of the details. So I would suggest have some prose to explain the lay of the land, what it is, and in addition to tables and comparisons. I think just tables and comparisons, in my experience, don't quite communicate the same thing. They're complementary, but prose is important. So in any case, I was going to draft some prose after August, as Carsten pointed out, and include the criteria and terminology description, and hopefully elicit some feedback from this group on the written document. I guess, based on the past experience of the documents we were recently reviewing, that might work better than just a PowerPoint solicitation. And then, is there a question?
Well, I'll wait until you're finished talking. Sorry.
Oh, I can, it's fine.
Well, yeah, so I was going to say, I'm happy to contribute. I think we need to focus on here is just getting the logistics set up so that we can do so. You know, setting up, you know, a GitHub repo or whatever, maybe a meeting with a smaller number of people so that we can just go on and work on things. I think I can start as simple as an email between, I think Michael Koster and myself volunteered already. I think others want to do that. We could start with us three. But I think we just need to get the logistics sorted out and get started.
Okay. Can do that.
So what's the right way to do this? Is a GitHub repo with an MD file or whatever for the an IETF template?
So for starting, it's actually even simpler to just do this on a wiki page.
Right.
But we can move that to a GitHub repo because the GitHub wikis actually are Markdown files, so you can just seamlessly move them over to repo and do a more structured approach.
Yeah, I think GitHub gives us issues and PRs and things like this, so I think that would be more appropriate.
Okay.
Easier to go blind to. So
Carsten, you're suggesting the WikiWiki, right, to start with?
Yeah, but Michael said he wants to have issues and pull requests and so on. So maybe we can really jump into a Markdown document right away.
Yeah, I think we down, then stick on a GitHub repo somewhere and get started. And then we can start chucking content in.
What's a good name for the repo?
I guess we should probably name it after the eventual probably publication. It's going to become an IETF. So isn't there a convention for like a author's name and then a title?
Yeah, let's do that part, making it an internet draft later, and just correct Markdown text for the moment.
Yeah. So I
think do we call this STL for semantic technology landscape, or I just need
the IoT. So I think IoT -semantic landscape might be fine.
Okay.
But the IoT needs to be in there just to avoid conflicts with other people doing stuff.
But it's going to be in the T2TRG, excuse me, in the Wiki.
Okay, that's fine. In that case, I think semantic technology is a fine repo.
Okay.
Or semantic landscape, maybe better.
Okay, so Carsten, you are creating that, right?
I'm creating it right now.
Yeah, that's what I figured. I'm just looking.
Great. And so I guess we also have like tables and CSV files or spreadsheet stuff too, right?
Yeah, we can cluster. As I said, I'll move the pros and then we can see what it amounts to and take it from there. I was going to, and then I think do a rough draft and solicit the group comments in terms of the direction and the level of content. I think that's what I would like to do before we get too deep into a particular path, whatever it is.
So I think the next logical thing to do here is to get volunteers, maybe organize a meeting so we're dealing with like 3 people instead of 20 or whatever. and work on handing out subtasks.
Okay. And
And
and one other thing I was going to propose, which we don't have to do now, but as a thing going forward, as we started describing individual standards, I think it would be very useful for a number of reasons to have contributions and at least feedback from STO authors of those standards we want to cover. And
Right.
so I think in the group we should put some pointers I have for lightweight M2M. Joaquin, I was going to do possibly from OCF Michael if he wants to be tortured.
yeah,
If he's a co-author and you too, they can, you know, we can shape it in a way that represents OCF properly anyway. And the same for Web of Things, because ideally, I want to keep the editorial authority with the authors of the paper, but give every input, get every input from the guys who actually do it and make sure that their stuff is represented fairly in the sense of whatever, in the context of the paper. So that would be ideal. So I would like to, with the group, help identify for the initial set of things. I said we have lightweight M2M. I think IPSO is now basically, I see them as the same. And OCF and WebOT is what I would start with. And then we can try to do that and then iterate in terms of, you know, are we getting the vocabulary, use it as a pressure test, are we getting the vocabulary right and the taxonomy and covering the right bases and then possibly expand it later for others. At that point, I would declare a version something or another of the paper and then go forward. I mean, and then we revisit and go forward. So that's basically the suggestion.
Okay, so people can send me their GitHub account so I can add them to this repository. We can start right away.
Okay.
Send them to me, I'll put them in the chat here.
Justin, August is in 2 days, and then we stop or what? Are we doing this the European way? I'm in Europe, so I'm inclined to take the August off. But anyway, we'll send emails. Michael, whom do you want to be the ringleader on the emails and on stirring the pot?
I think you're this ringleader.
Okay.
But
Yep.
Thanks. Yeah. By the way, this is something I've been wanting to do for a long time, and a lot of people want to see something like this done, but fewer people want to bother with it. It's a sizable task. It's one of those. It should be done. Okay. Justin, you want this in the chat note, or you want actually my
whatever works for you.
I'll send you email. My WebEx went to some minimalistic mode with the file. It's playing numbers on me. I'll do. Yeah. Okay.
Okay.
So that's what I had.
So that's how we can get started. We have 10 minutes left, and I really wanted to hear Sebastian's idea. So I hope you don't mind if we switch to Sebastian now. Sebastian, can you go ahead?
Yeah, I start to share my screen. So can you see my browser? Okay. Well, so I would like to present the idea which we would like to start now at a T2C Web of Things group, namely to define for the COA protocol RDF representation for that. So maybe you are already familiar with the Web of Things and thing description, that we have also covered protocol bindings in there. So that means we are, first of all, thing description are independent of protocol, so you can define your property action events. And if you have knowledge about a protocol which is used for exchanging the data, then you can also specify it. Yeah, and so that means if you have HTTP as example, then you will provide the URL of the resource, and you will provide a method which have to apply to the resource, or if you have a get, put, post, etc. And the idea what we like to do is that we are try to cover as much as possible protocols which are out there. So I would say the most heavily used IoT protocols like MQTT, HTTP, CoAP, etc. So there is the idea to cover them. And for HTTP, there is already RDF representation available. So that means we can simply reuse existing term definitions which can be assigned to HTTP. So we can simply reuse the ontology file for HTTP. So we can, for example, name the method name or method term to say, okay, this resource has to apply a get method, for example. And for the same thing, you would like to do for the other protocols, like for CoAP. And we have already written down this terms, which I think is a kind of small set, which would be cool to have also the terms defined as a RDF, so that we can simply integrate them in a thing description. And you will find here in the binding template document already the first proposal of the terms. However, we don't have RDF representation behind. So we don't have ontology, which simply lists all the terms in a formal array, which we can simply integrate in the thing description. Yeah, and this is the idea of the work, that we are starting this kind of process to define an ontology, RDF ontology for CoAP, where we can use or reuse the existing terms, which should be very equivalent what you can find also in the CoAP specification, also in RDF-based representation like in thing description. And right, and the reason why I like to start the discussion here, so first of all, I would like to make aware of that. So we did around 1 month ago a kind of kickoff meeting, and one important point is that the IETF should be aware of that activity, and we would also get a, I would say, kind of official okay with that. That is a kind of agreement that we are doing this kind of work, because CoAP belongs to IETF, as you know, and what we just want to do is to make our RDF representation of the most common used terms in CoAP there, and that's the reason I want to make aware of that, and ask if there's any objection on that to starting this work. So the idea is that Klaus Hartke is coordinating this kind of work, and also other members will contribute to this contribution, and also it's a call to everyone who is also into this work to to join this activity here. And right. That's all, and yeah, I'm open for a question, any feedback, etc.
So one thing that struck me when I looked at the page is that this was essentially a copy of this file. So maybe you can just pull in that file and you're 95% done. Do you see what I pasted in the chat?
Yeah, I will open that.
Well, it's an XML file, so there are readable versions of that.
Yeah, so I think Carson, we want is a machine readable version of this data expressed in RDF. And in fact, we actually want to have a fixed URL for it so we can reference it in a context file in the thing description.
Yeah.
So I think part of it is simply mechanical. It's simply taking this information you just pointed at and converting it into a TTL file that we can link to.
Yeah.
Or yeah, set of definitions in JSON-LD.
maybe a couple of lines of XSLT is all that you need.
Maybe. I think we also, though, want to have it available at some fixed URL somewhere. And maybe this is someplace, something that could exist. Where does this go on the web, right? So that's the other question.
So I have some problem to open the link. Ah,
But it's an XML file, so the browser may not be able to show it.
okay.
Yeah, so I guess the question is, if it's XML, then in theory there should be a way to use a XML pointer or something to point a particular thing in here. And that can be the link that we use in JSON LD for each of these concepts, right?
Yeah, I mean, this is maybe a very good input. And I mean, to be clear, so we don't want to change anything. Yeah, we want just to bring all the co-op as it intended to be used to, also in the same meaning there. Yeah, and I was not aware of this file. I'm still struggling here.
So it may not cover everything, but it covers all the things that are growing. So you may need a couple more things that actually come from the document. But all the things like option space, method space, RT values, and all this stuff are being maintained by IENA. So having the ability to pull in IENA XML and turn this into something like RDF might be something that we should be cultivating here in Wishy.
Yeah, if we could automate the process of creating the RDF from this, that would be great.
Yes. And again, it's going to be a few lines of XSLT or maybe some Sana programming language. I don't know.
Well, do we have somebody who's willing to volunteer to stab at it?
Version, yes.
Is there somebody willing to do to volunteer to take a stab at prototyping that? Who's an XSL?
I'm not exactly proficient in XSLT or RDF, so I cannot volunteer to do that. But maybe somebody else can.
Yeah, I think it's a very good idea, and I think I think the work is actually quite easy. Yeah, it's just, I would say, someone take some time, and I think we will be finished in maybe in 2 days. Yeah, and I think it's not this is not a rocket science what we're doing here. Yeah, but if you have already this kind of full list here, then it helps quite easily to transform this in an RDF representation. Yeah.
Yeah, well, not only it's the full list, it's in XML, so it's a structured document internally, right?
Yes.
So we just need to figure out how to parse it and turn it into what we need. And again, XSL can help us pull up the pieces we need.
Let me show how the XML looks like. Hello, computer.
I can hear you.
Yeah, it's what happened?
It takes 2 minutes to share, right?
So I already have some tools that download the core parameters and do stuff with them. So my plan was just to update those tools in the usual one afternoon and then send the results back to W3C. If anyone wants to help with that, please ping me and we can have a discussion.
But I think it's not just a matter of sending it to W3C. I think we want to have, from a user's point of view, is the ability to add a single line to their context and get a bunch of definitions they can use inside a TD. So we actually need to have these definitions posted somewhere available, right? And
yes, and then we need a little bit of glue to put those dynamically generated vocabularies together.
Yeah, I think we need to publish, a note or something somewhere, or an RDF-RC explaining how to use these terms inside a JSON-LD document. So that's kind of where the protocol binding. So we could do that in W3C, but is it the right place to do it? Is the other question we have.
Yeah, since Klaus is already the designated expert for about half of this file, he knows his way. Yeah, so what you're seeing right now is the registry for method codes. So the fact that get is a 1 and post is a 2 and so on, that's in this registry. And then we have the response codes, which is in this registry, and so on. So that should be pretty easily possible.
Yeah, it's perfect. It's really
Yeah.
perfect.
So I guess
So
one question, Sebastian, I had, what about OCF? So OCF uses some extensions, some header extensions. Do we want to leave that out or pull in certain extensions, or is there just some general mechanism to easily do those? Oh, they're in here.
I mean, at the moment, we're just addressing the core as it is, right?
Well, yeah, but if you're in the INA spec, we're looking at it right now. So if it already exists in the INA, then we should get it for free. Great.
Yeah, if it's already in there, then we can also cover that. Yeah.
So this is option 2053, which Michael Costa registered for the OCF content format version. So that's all in there.
Fantastic.
So, well, we are done.
It's out of time. So
Yeah, sure.
maybe
Yeah. I mean, and again, I mean, one of the intentions is also to, if there's any objection on that or what we are doing there, please let us know, because this is mainly the W3C is quite important that we're not doing something what you don't like. Yeah, so because co-op is IETF, and if you are against this, what we are doing there to have also RDF representation, then I think we have to talk about this further.
One thing we're saying though is that the protocol binding document would be an informative document and would point back to, this probably as the normative definitions, right? But we're still saying here's how you use it inside a TD document. And here's an RDF file that has the same information.
So if we can get this that converts the XML into RDF in a form that IANA can use that tool, we could maybe even make sure that IANA is in a position to publish this RDF file. I think that would be a very good way of handling this.
So
To run a schedule job on GitHub Actions.
Yeah, that's the second best, but I think the best solution would be for IANA to own this.
I think so too. So who can contact IANA?
Let's have
also,
the RDF file and a converter first, and then discuss with IANA how we can make this permanent.
Yeah, that sounds like it, right? And that would cover like so much more than just core too. Sorry, I have to run, but it sounds like a really good direction.
Yeah, I like this idea as well. Yeah.
Great. So we're out of time. Please answer the doodle that will be sent to the research group mailing list, and see you all in 6 weeks.
Okay, vacation.
Yeah, have a nice vacation. Bye-bye.
Thank you. Bye-bye.
Thank you. Thank you all. Have a nice
Everyone.
vacation.
And bye.